So I'm going to translate these statements as I read them. The positive integer x is divided by 5, remainder is 3. So that's kind of the standard approach. That's the remainder algorithm, meaning it's a multiple of 5 plus 3. Q1 is some integer, quotient. Generally, that's the form we use. And then when x is divided by 7, so a different quotient, remainder 4. We have similar information about y. And I guess it's the exact same thing. Actually, I should use a different quotient here. And then 7q4 plus 4. They're asking about which of the following must be a factor of x minus y. So you'll see that if you subtract those two, because this is, in both cases, they're a multiple of 5, remainder 3, you get x minus y is 5, q1 minus q3. And then if we do that here, you get x minus y is 7 times q2 minus q4. The key thing is the difference is a multiple of 5 here. And that second piece tells you it's a multiple of 7. This is some integer, q1 minus q3, q2 minus q4. That means for both of these to be true, x minus y must be a multiple of 35 because they don't share any other prime components. So, which is 35. So x minus y must be a multiple of 35, which means that 35 must be a factor of x minus y. So the answer is E. You could, I guess, use it with numbers because we have the answer choices. But because it's must be, you have to make sure that you can establish that under all circumstances that's the case. So, for example, if x is, so you could generate example. Actually, let me do it for x in both cases, where they're telling you that the remainder is 3. So you start writing multiples. Smallest would be 3. Next one would be 8, and then you're just adding 5 to it. 18, 23, 28, 33, so on and so forth. And then the second condition tells you it's 11, and then you add 7 to it, 18, and 25, 32, 39, 46, 53, so on and so forth. So the first example for x is 18, and that would be the case for y as well. We just need to figure out what the next one is where they both satisfy both of these conditions. So you can either keep writing them out. Let me just see, 33, so then it's going to be, I'll do it here, 38, and 5 is 43, 48, 53 is the next one, right? So you could pick x to be 53, y to be 18, and you'll see the difference is 35. But that's not enough to show that it must be, because, and I guess that's the downside of picking numbers. You'll have to kind of use some more examples. Especially can be tricky if there are maybe smaller numbers that could be, that are in the answer choices, because you would have to negate the other ones. And maybe actually, you know what? No, in this case, it's easier because in this particular case, x minus y happens to be 35, then none of the other choices are a factor. So that actually does work here. So let me take that back. So this would be an approach you can take. I just gave you the general approach that I use. It's just easier for these types of questions with asking factors and multiples and so on and so forth. So summarize, the answer is E.